Oh, I messed up somewhere. All right, no, I haven't messed up. I just usually do a step sooner than I hear. So I've got three variables here, which doesn't seem like I've really made life a little bit simpler, but we can now put Q in terms of X. The uniform density makes that more convenient. So based upon this, I have multiply both sides by dx. I get dq is lambda dx. So I hat k sub e big Q integral of x lambda dx over r cubed. I'm now down to two variables. And what is the relationship between r and x? Think about the triangle.
R squared equals x squared plus L squared.
Yep. R squared is equal to x squared plus L squared. So R is x squared plus L squared to the 1/2. Plug that in. We get I hat KEQ integral x, I bring the lambda out also, lambda out, dx over x squared plus L squared to the 3/2. It's a 3 there. And now we have it in terms of a single variable. How do we solve it? Oh, single variable, we should do limits of integration next. What are the limits of integration? Negative infinity to infinity. All right, so how do we solve it?
I think U substitution would cancel the top x, so I think U substitution would be a good start.
Say that again?
U substitution probably.
What are we substituting in there?
U for x squared plus L squared.
So du 2x dx. So we are now left with I hat k e big Q lambda over 2 du over u to the 3/2. And that's the relationship there, so still a negative infinity to infinity. What's that integral?
Would it just be, would it just be 0?
Pardon?
Would it just be 0?
Why?
Because it'll be 1 over u basically, and 1 over infinity is 0.
Well, let's take it step by step. Find out if that's right or not. There's another way of approaching that also, but. So the integral of u to the negative 3/2 du. flashback to math, doing anti-derivatives.
Negative 2/3 times u to the negative 1/2.
If I took the derivative of that, I'd end up with 1/3 u to the negative 3/2.
Yeah.
Alright, so that now brings us to so I have the negative 2u, that 2 will cancel out with that one, so I have negative I hat KEQ lambda times 1 over square root of u from negative infinity to infinity. And as Sarah said, this ends up being 0 minus, oh, wait, hold on. This would be, this limits of integration would change. So if I plugged in infinity, I'd get infinity. If I plug in negative infinity, I'd still get infinity. Something doesn't seem right about that. You do end up with 0 now.
Is that even possible to range from infinity?
It is not. So if we plug back in, which clearly x squared plus L squared from infinity to negative infinity, you would get 0 minus 0. I just think about those limits with you. All right. Now, so we've established that in the horizontal direction, the net force is 0. That should not be a surprise. Because for every point to the left of 0, we have a point to the right of 0 with a force pointing in the symmetric direction that way. All of the points here, which would have a force in the positive horizontal direction, there's another one in the negative horizontal direction, so all of those should cancel out. So by symmetry, we should have gotten 0. We didn't have to do the math, but we did for fun. However, let's do the other one now. The J hat part. Questions on this before I erase? Okay, it is recording. All right, so we have excuse me, the force in the vertical direction is equal to the integral, case of E, Q, dq over R squared L over R J hat. Bringing the constants out front and then putting dq in terms of x, we end up with the integral, bring the constants out front, J hat, case of E, Q. This would be lambda dx over R cubed, and then L would come out front. So we have J hat, L lambda, k sub E, Q, integral dx over r cubed. We have two variables here, so we need to get it in terms of a common variable. We'll use the same substitution we did before between r and x, and we end up with j hat L lambda k sub e q integral dx over x squared plus L squared to the 3/2. And how do we solve that? DJ, I'm looking at you because you had the last one.
Well, it's not use substitution, I don't think.
That is correct. Don't forget, there's the math way and the physics way. I think this is count 2, not count 3. Pretty sure. So all of you would have had to have had count 2 by now. How many have or are in count 3? No count 3 for either of you? Okay. That's okay. Trig substitution.
That would probably be why I'm not thinking of
That is count 2, right?
it. Yes.
Okay. So all of you should be dreaming that stuff. Eating, dreaming, all the good stuff. That's the math way. You would let x is equal to L tan theta and work it from there. What's the physics way?
Look it up.
Absolutely. You look it up. And it would be nice if I have it written down somewhere. No, it's not gonna be there. That's the one we just did. Well, that's where I actually go through the trig substitution. No. I don't have it written down. Oh, nope, there we go. This is equal to, or actually if you looked it up, you'd get the integral of dx over a squared plus x squared. The 3/2 is x over a squared square root of a squared plus x squared. Beautifully written, incredibly legible handwriting. So this becomes j hat L lambda k sub e q times x over L squared square root a squared plus, not L squared plus x squared. From negative infinity to infinity. And what is that equal to? Well, we can cancel some stuff out here. One of those L's cancels out with that L. So I have j hat lambda k sub e q over L infinity over the square root of infinity squared minus negative infinity over the square root of infinity squared. Absolutely horrible math notation, perfectly fine in physics.
Can that be indeterminate?
No, it is not indeterminate, it is very determinate.
Those infinities equal to 2?
It would be 2. Whatever it's just an incredibly huge number here. It's an incredibly huge number over, well, if I square it, take the square root, I'm just left with an incredibly huge number. So that would be 1. Here, again, that part is 1, so I got 1 minus negative 1, or 2. So we end up with the total force, given our convention over there. The force on big Q from the line, from little q, is equal to J hat 2 lambda K sub E big Q over L. Quick check to see if this makes any sense. L's a positive number, Q is whatever that thing is, assumed to be positive, KE is positive, lambda, we assume that it is positive because we've got other information. That puts the force away from the line, or in the positive J hat direction when it's sitting there, and so that part makes sense. I know that the closer charges are together, the stronger the force, and so as L gets smaller, the force gets bigger. That checks. As lambda or Q get bigger, the force should increase. So this all seems to make some sense. Questions to here? All right. Now, if you look that formula up, that's probably not the way it's going to be presented. So let me introduce another constant to you. The electrostatic constant, K sub E, is equal to 1 over 4 pi epsilon sub 0. Where epsilon sub 0 is known as the permittivity of free space. Permittivity is something that's going to pop in more detail in chapter 27, 26 or 27. It is a measure of how a medium reacts to the presence of an electric field, or at this point, to the presence of a charge. But that's a baseline number, and there's a baseline number, which is roughly 8.85 times 10 to the negative 12th Coulomb squared per Newton meter squared. Now, I will tend to use the case of E because it's less writing, but later on I'm just going to switch over to whatever 4 pi epsilon sub naught, whatever seems to be the most convenient at the time. So that formula over there now becomes, so the force on Q, J hat, oh, there we go, 2 lambda Q over 4 pi epsilon sub naught L. And then that 2 is going to cancel out with half that. So we have that formula there. That formula is going to pop back. Later on, we're going to come up with a faster way of solving that. where the calculus is already built into the problem. Questions? All right, let's take a break. Come back refreshed, ready to go. Do some more calculus-based problems, because I don't want you leaving here crying into your pillow tonight because we didn't do enough calculus. I don't really want you crying into your pillow because we did too much. That's why I will always do just the right amount. I do want to comment on attendance policy. I really can't remember what's in the quiz, but a new policy has come down that if you are inactive for 14 days, you are dropped. So inactive means, at least for us, butts not in the seat, and you have not submitted anything. If you look under, I think I put it under coursework, there's something called the dummy assignment. That is, if you, for some reason, we've talked about it, and you are gonna be gone for a lengthy amount of time, submit something in a dummy assignment. It just, all you need to do is submit something. I'm not gonna look at it other than to see that it's submitted. And that would still keep you active. All right.